Imaging sensors for DSLR and cooled astrocams are getting better every year. The majority of these sensors are targeted for the consumer and security markets. Very few are targeted for the astrophotography community. Taking photos in brightly lit conditions is taken for granted these days. Even taking photos in dimly lit conditions is becoming a standard feature. Taking photos in pitch blackness is an extremely small market, and that's where deep sky object astrophotographers live. Most astrophotographers have to deal with light pollution. Astrophotographers are not interested in getting quality photos of a light-polluted sky. They are focused on imaging a distant galaxy whose brightness is tiny compared to the sky glow generated by our modern cities. This sounds like a losing proposition, the equivalent of trying to take a photo of a polar bear in a blizzard. The good news is that it's not. Lots of research has been performed regarding the characteristics of light, and the one characteristic that allows astrophotographers to deal with light pollution is called the superposition of lights. Light can be coherent or incoherent. Coherent light is generated by lasers, and this type of light can generate interference patterns in laboratory experiments. The bulk of light we see in nature is incoherent light. Light pollution, sunlight, and the light from astronomical targets are sources of incoherent light. These sources of light do not generate interference patterns. Instead of interference patterns, incoherent light simply adds together. The dim brightness of a distant galaxy is simply added to the sky pollution. This means that if we can subtract the brightness caused by light pollution, we can recover the light from a distant galaxy. Dealing with light pollution does require more photos to be taken, but it is possible to take astrophotos. Regardless of whether you are imaging from a light-polluted city or from a very dark site, deep sky objects can be extremely dim. To extract that faint detail requires you to deal with noise and distortion caused by your telescope, your camera, and light pollution. Depending on what you read on the web, you will learn about several sources of noise in digital cameras. The calibration method in CaLIGHTs focuses on read noise and dark current. The distortion I have mentioned is due to dimming at the edge of your light frames and by dust particles or fingerprints collecting on the glass surfaces of your telescope's optics. There are still issues of transparency and seeing to deal with which cannot be addressed via calibration. These issues exist anywhere on Earth. Transparency is like the polar bear in a snowstorm. You can't see through it very well, so objects tend to disappear from view. Seeing refers to the twinkling of a distant star. It may look pretty to most people, but to astrophotographers it means fuzzy photos. Luckily, issues with transparency and seeing vary each night. This means we can have an ideal night of imaging once in a while, which keeps us inspired to keep going. The need for image calibration never varies. It's true that you can get better by purchasing better equipment, or you can get better by mastering the techniques needed for image calibration. As always, the choice is yours.